Hi, this is Jeline from the Honors Tutorial. Welcome to part 2 of our topic, and that is factoring using GCF and common monomial factor. This is for Mathematics 8. So let's have our next example here. So the direction is still determine the GCF of the following. So GCF again is greatest common factor. For number 3, we have here 10a cubed b squared c and 16a squared bc squared. Okay, so let's solve for this and let's have our solution under this given. So let's just write solution here, and then let's focus first on the first given, which is the 10a cubed b squared c. So let's write letter A, and then let's have here the numerical coefficient first, and that is 10. So think of a prime number that can divide 10, and that is 5. If you're thinking of 2, it's fine because it can also divide 10. No worries about it. 10 divided by 5, that's 2. Think of a prime number that can divide 2, and that's 2 also. 2 divided by 2 is 1. For a cube b squared c, let's solve it here. So that is a cube b squared c. If you're going to expand it, then we should have 3 a's. So we have here a times a times a. And for b, we should have 2b. So that's, let's say b times b. And for c, we cannot see any exponent, but automatically it is 1. It is because if your exponent is equal to 1, it should be an invisible number. So times c. So now we can conclude that the factors of 10a cubed b squared c is 5 times 2 times a times a times a times b times b times c. So this is the factor itself. For the variables, I'm just letting you see how to expand it. But remember, during our part 1 of this video, I have mentioned that there is more easier way than having this expanded. Okay? So you should master it. And if you don't watch it yet, then visit our YouTube channel, that is the Honors Tutorial, and look for it. For letter B, we have here 16 a squared bc squared. So let's have the number first, or the numerical coefficient. Just think of a prime number that can divide 16, and that's 2. 16 divided by 2, that's 8. Think of a prime number again that can divide 8, and that's 2. 8 divided by 2, that's 4. So we will be writing 4 here. And then think of a prime number that can divide 4, and that's 2. 4 divided by 2, that's 2. Think of a prime number again that can divide 2, and that's 2. 2 divided by 2 is 1. For the variables, we have here a squared b c squared. So for this kind of example, if we expand it, it will become, that's a times a times b times c times c. Okay, let me just use other colors so I may see it here. So that's a times b times c. Okay, that's correct. So therefore, we can say that the factors of 16a squared b c squared is this. 2 times 2 times 2 times 2 times a times a times b times c times c. Okay. Now, we know the factors, the prime factors of each term. Now, let's look for the GCF. So I will be using again the right side of this equation or the board. Okay, I will be writing the factors of 10a cubed b squared c here. Okay, let's rewrite it. Then it is 5 times 2 times a times a times a times b times b times c. Okay, so this is the factors of 10a cubed b squared c. Next, of course, we still have the second given, and that is 16a squared b c squared. Okay, so I will be writing also the factors of it here. So that's 2 times 2 times 2 times 2 times A times B times C times C. Now let's look for the partners. Let's have another color. 5 and 2, no, because they are different numbers. 2 and 2, yes. Okay, good choice. A and 2, no. A and 2, no. A and A, yes. It's a good choice from here. And then B and A, no, but they can still be partners here. So this one and this one, it's fine. Next for B, we have here B and B and C and C. And then for another, hmm, for another GCF, let's solve for it. So GCF is equal to 2 times A times A times B times C. Okay. Now, let's multiply it. So therefore, GCF is equal to 2. A times A, that's A squared. B times C, that's BC. So this is the GCF for this example. So this is it for part 2 of our topic. I hope that you have learned something today. Next a video will be for this the same topic but with common monomial factor. Watch out for that, okay? So thank you for listening for the day. If you have inquiries about us, just message the honors tutorials page. Thank you and God bless.